Hi guys, welcome to your lesson on using a triple beam balance. We're going to use it to measure the mass of an object. Your success criteria will be for you to be able to accurately measure the mass of an object using a triple beam balance, and we'll actually do this in the laboratory. I'll give you several objects, you'll use a triple beam balance to measure their mass, and we'll see how close you can get to their actual mass. So let's look at the triple beam balance. On the left side we see the pan, which is where we put the object we're measuring, and we see three beams. The first beam is in 0.1 gram increments, all the way to 10 grams. The second beam is the largest beam, and it's up to 500 grams in 100 gram increments. And the third beam is in 10 gram increments. And you'll notice that there's little slots on the last two beams we talked about, and that helps you to know that you're exactly on the right place for that measurement. Over here, you'll see two lines that are supposed to match up. If they match up, then we know that we have the right mass on these beams. So, let's measure the mass of the fishing weights. I have some fishing weights that will be like the ones you're going to use in the lab. I'm putting them on the balance. And we're going to move the smallest increment first because we know it's really small. We're going to try that first to see if it works. So we move it down to 10 grams, and no, it's not quite enough to balance it out. Because that beam is higher than the base, the line is higher than the baseline, then we know it's more than 10 grams. So let's take it back down to 0 grams. We need to make sure it's lined up on the 0. And then let's move this beam back here. We're going to put it on 10 grams and see how we've got that on 10 grams. And we know it's more than 10 grams, so we expect to see this not lined up. But we want to see how much it does weigh, or how much mass it does have, excuse me. So we're going to move this tiny one again, and you'll notice that the line is getting closer and closer to being even. So we just move a little bit at a time, and each time we got to look to see where those two lines are. Now they look like they're even to me, so let's look and see. And we'll see that's on about 1.4 grams. But there's 10 grams back there, so 10 plus 1.4 is 11.4 grams. So that's how much this particular set of lead weights weighs, or how much mass it has. I keep saying that. A lot of people do get weight and mass mixed up, so let's not do that. Now let's weigh something that's a little bit heavier. We're going to take it back down to 0 again. Make sure everything's right on 0. And we're going to measure the mass of this beaker. Now this beaker's got some food coloring and water in it. And the beaker's pretty heavy, so I think it's going to be at least 100 grams. So I'm just going to start with 100. And I make sure it's in there. And that's not enough. So let's go to 200. I'll make sure it's in there. And that's not enough. So let's go to 300. Oh, that's too much. So now we got to go back to 200. And so it's somewhere between 200 and 300. Now you can't put this in between 200 and 300 because you can't measure it accurately. So what you have to do is use the 10 gram increments back there to see where it is. So we know it's more than 200 and we know it's less than 300. So we're going to use 200. I'm going to guess 220. Let's see. Nope, it's more than 220. So let's go to 230. 230. It's more than 230. So let's go to 240. It's more than 240. So let's go to 250. Oh, well, now we know it's less than 250. So now we go back to 240. Yep, it's more than 240 and less than 250. So now we can go to the small increments again. It's not 251. Excuse me, 241. It's not 242. Let's see if it's 244. Huh. Well, we see it bouncing, so we know we've done something good. We don't want it to bounce too much, though. So now, look at those two lines. The one on the beam on the left is a little higher than the one on the right. So we're going to go back over here to our increments again. And we're going to add a couple of tenths of a gram and see what happens. Now that's at 4.3. If you look at it real careful, and let's look, and they're matching. So it's 244.3. Can you see that? 244.3. And that's how you read a triple beam balance.